Hey guys, so today we're going to be talking about the Hardy-Weinberg equilibrium. The Hardy-Weinberg equilibrium is used to find the frequency of alleles in a population. So, find frequency of alleles in a population. Okay, sorry. And in order to be able to use Hardy-Weinberg, there have to be 5 things present in your population, or else Hardy-Weinberg doesn't work. So the 5 things that have to be present are no mutations, random mating, no natural selection, the population size has to be very large, and there cannot be any gene flow. So that means that there can't be anything like immigration, transfer of pollen, etc. So in order to use Hardy-Weinberg, all of these things have to be present in your population, or else Hardy-Weinberg is not a viable option to figure out your population, frequency of population. So let's try a problem where it reads, in a population of pea plants, the frequency of the tall, big T height allele is 0.8, and the frequency of the short, little t allele is 0.2. What is the probability that the pea plant will be big T, big T, big T, little t, and little t, little t? So you have this information, which is 0.8 and 0.2. What do you do with that? I'll show you that P is your homozygous dominant. Your Q squared is homozygous recessive. And your 2PQ is your heterozygous. So, all of these numbers that you plug into this equation should add up to 1, which will be 100% of the population. And so that means that you account for everything that you're trying to solve for. So, to solve this, you have your P squared, which is your big T, plus 2PQ, big T, little t, plus your Q squared, which is your little t. And so from the problem, you know that this is 0.8 and that this is 0.2, and that should add up to 1, which it does. So how you solve this is simply that you will have P squared, which equals 0.8 squared. And so 0.8 squared will equal 0.64, and that is how much of the population will be big T, big T. And then your Q squared will equal 0.2, and you want to have that squared as well. So that will equal 0.04 little t, little t. And then you'll have your 2PQ. So that will go into 2 times 8, which is your P, times 2, which is your Q. And that will equal 2 times 0.8 times 0.2, and that will equal 0.32 big T, little t. And so these are all your answers for your problem.